Hi all, we're building Toast to help with 3 problems we found in professional firmware development. We think there's too many disconnected tool chains, there's definitely not enough modern testing, and writing portable code is hard. We're going to show you the features we want to build through a simple smart thermostat project in 4 simple steps. Now, starting a project is super simple. We just run Toast init. What we'll do is we'll choose a name. Let's go with smart thermostat, and we'll choose the NRF52. Alright, great. So once we've done that, a project template has been created. First thing we're going to look at is this project configuration file. If you want, you can define your hardware setup here so that Toast can use it for emulation later on. Now, the exact temperature sensor we're going to be using is the DS18B20. So I'm going to install the library for that from the terminal here. And what this will do is give us some utility functions which will help us interface with the sensor. Now, there's also a ton of useful optional settings here, including the bootloader and some compliance checks. Final thing, we are going to write down the exact configuration of the hardware. I'll just copy this in here. So this will be used later for the emulation. Before we do move on to writing the firmware, we're going to check that the hardware configuration is all working using our quick verification command. Great, so we'll see here that no serious errors are actually coming up. Great, let's move on to actually writing the firmware then. So if you've already written a code base, then you can use it without any modification and still use the emulation and the flashing tools that we'll talk about later. This main entry point is completely empty by default. There's no extra baggage if you don't want any. And finally, we're going to use Rust in this demo, but you can use C or C++ if you would like to. So first things first, we are going to import that sensor library we installed into this file. Now, I've written a script earlier for my temperature sensor, which I'll copy in here. And let's just quickly look through this script. First things first, this will initialize the sensor from our config file. Second, we'll take a temperature reading from that sensor. Third, we'll actually write to a memory address, that specific temperature value. And finally, we'll go into deep sleep for a second. So we're basically taking a measurement once every second. There are some other standard libraries which Toast comes with, which can help with other production features like OTA support, MQTT messaging, and log collection, etc. But we aren't going to use them for this simple project. So we've got the firmware, now we can move to actually testing it using our emulation framework. First things first, we're going to create an emulation of our components. Now we can install logical emulations for common components, or you can write one from scratch for your own custom component. Anyone can upload emulations to our repo and anyone can install them. For our very common temperature sensor, we can simply import an emulated version provided by its library in the config file. We are going to modify it slightly just to show you how you do this, and we're going to add some sinusoidal noise to its output value just like this. So we can change around the magnitude and the frequency of that noise in our emulation. So you've got the emulated component. Let's move to the actual testing script now. Again, I'm just going to copy in one I wrote earlier. First, we initialize the device. Second, we'll set its temperature to 20 degrees. And then we'll run the sim. So what should happen is the temperature sensor should write that value to memory, and we can test that by asserting whether or not the value at that address is in the correct range, so 19.9 and 20.1. So that's the whole testing script. To actually run the script, we just do toast test, and we'll let that run, and the device is running, and there we go. So the value is in the correct range. There we go. This was all done using scripts in the CLI. If you want to actually visualize what's going on, you can use our GUI. So this will take you to a locally hosted GUI, and this GUI will lay out the hardware configuration that you defined, and it will allow you to add more components whilst you can change the variables in real time. So in this window here, you can see the serial output of the emulated chip, and you can also actually modify the memory of the chip and the peripherals. Okay, so we've created the firmware and tested it. Let's actually get it onto the chip. Two choices here. We can run in debug mode. So this will use breakpoints actually set in your IDE, and the code will only run up to a certain amount. So you'll see here we've hit the certain breakpoint. Or you can actually just flash it fully onto the device. We'll let that run, and that will finish up the project. So, and that's on the chip. So we've successfully created a piece of firmware. We've tested it super smoothly using our emulation, and then we've actually deployed that to our device. That's a quick tour of Toast. We want to hear any and all feedback you have on what we want to build. If you think something looks exciting, then definitely let us know in the feedback form on our website, toastthedemo.com. See you soon.